Hello again, and welcome to Section 3, Advanced Smart Contracts with Solidity. In this section, we're going to be covering a wide range of commands and implementations for smart contract programming with the Solidity language. We'll start with a hands-on overview of a complex smart contract. After that, we'll learn all about the different data types and variables that are available to Solidity developers. Then, in video 3, we'll take an in-detail look at two of those data types called mappings and structs. Next, in the video titled Using Function Modifiers, we'll be learning how to change the default behavior of functions and enforce better security of data in our smart contract logic. Finally, in assertions, control structures, and emitting events, we'll be looking into how Solidity and the EVM can handle logging and error handling. And we'll also be briefly looking at the control flow commands that you may recognize from other programming languages, but also the ones that you may not be familiar with. In this video, we're going to be taking a deep dive into a complex smart contract that provides DApp users with the ability to bid on an open auction. Now, if you go to solidity.readthedocs.io and you click on Solidity by Example, one of the examples that you'll find will be the simple open auction that we'll be going over today. As it says here, the general idea of the following simple auction contract is so that everyone can send their bids during a bidding period. The bids already include sending the money, well, Ether really, in order to bind the bidders to their bid. If the highest bid gets raised, meaning it gets replaced by a bid higher, previously highest bidder gets their money back, or at least they'll be able to withdraw their money from the smart contract. After the end of the bidding period, the contract has to be called manually for the beneficiary to receive his money. Contracts cannot activate themselves. Now, included with today's video, we'll find that we also gave you the output for this simple auction contract. So what you can do is go ahead to remix.ethereum.org and you can load the smart contract into Remix and you can compile it so that it is green. Once it's compiled, we can go ahead and deploy this contract. But in order to deploy this contract, we do need to enter these params. Now, the beneficiary is obviously the person who's going to be offering up some sort of good or service. Say, I'm launching this smart contract, I have some art for sale, and the winning bid will receive this art, and I will be the person receiving the money from the winning bid. Well, the person receiving the money from the winning bid is what we're declaring here as the beneficiary. Now, of course, the params that we do need to be sending when we deploy our contract are declared here in the constructor. So we've discussed what the beneficiary is. I'm going to go ahead and set that value to be myself. I just have to log into MetaMask. You can see I'm already running the Rinkeby test network. Obviously, we are good to go with this particular account, so we're going to go ahead and copy the value to the clipboard. And I am now the beneficiary. So at the end of the auction, which is also a time field, which we're controlling by a uint, you can see here from the Solidity documentation person that developed this code, they put some comments for us. Because if we look here, actually the constructor of the contract, the auction end is just incrementing now in Solidity. And I can tell you that this special command, this reserved keyword now, what it actually does, they did offer a clue here, is it will return a Unix timestamp that gets recorded in the block as the block's timestamp. So this now is actually just getting incremented by this value here, bidding time. I want to warn you right now, try not to, when you're doing this yourself, try not to make the bidding end time too far into the future, because obviously if you make it too far into the future, say if we wrote something really long, 100,000, a million seconds, that's going to be a really long time. We won't be able to use all the smart contract functions. More importantly, the beneficiary, who in this case is going to be ourselves. Here we go. So the beneficiary, which we've made ourselves in this case, awarded with the winning bid, they need to be able to withdraw their money. So what we're going to do is, let's just think, and we can use the JavaScript console down here for a second. So maybe 60 times 5, we'll go 5 minutes. We'll go 300 seconds. Now we have 5 minutes to do our bidding. So we can go ahead, confirm this transaction, which will deploy the contract. Now, of course, we're going to have to wait a minute. We can see in Remix that Remix is aware that the block is confirmed. So we see that the transaction was mined and the execution did succeed. And now we have our contract is available to us here. Now we enter actually a slippery or existential moment, because actually if we try to bid on the contract right here, we're just going to ignore this gas estimation. Basically, because we're doing a blind auction, the smart contract itself, it doesn't know what the value of the transaction is supposed to be. So because it could be infinitely large, it could cost infinite gas. Suffice to say, we're going to send it a very finite value here. So the existential slippery crisis that we have here is that we actually can't perform this particular contract execution. We can't call the bid function from MetaMask. I know that that's the way that we have been interacting with our contracts up until now, but the reason why is because we have to bid some Ethereum. We can see that the value that we're supposed to be sending actually is 0. Edit the gas. It doesn't actually let us edit the value that we're going to send. So actually what we have to do is reject this transaction, and we're actually going to need to interact with our simple auction contract from a bidding standpoint with a different wallet. But what we need to do is we want to use the same Ethereum address in our other wallet. And I've included some code in your section 3 folder for the video. It should be called myetherwallet-3.2.1. It should look like this. We're going to be using that in a second. But the first thing that we want to do is, because you probably have your Rinkeby testnet on MetaMask. So what we got to do is transfer it out of there. So in order to export our Rinkeby account that we have here in MetaMask to another wallet service provider, we have to export our private key. What we can do is click these 3 dots for account options, account details, and then the method for doing so is right here. For obvious reasons, I will not reveal. But of course, you can click this and copy the value that it does give you for your export private key. Okay, so now I do have my private key exported into my paste buffer. Now, of course, what we're going to do right now, we could do online at MyEtherWallet. And the source code that we're going to be using and loading locally, of course, does come from MyEtherWallet. However, for obvious reasons, we shouldn't be sending things like our private key online, just like I didn't want to reveal my MetaMask private key to all my viewers here. So the advantage of taking the wallet code that I've given you, I just have gone now into the directory, and everything is compiled into this index.html. The reason why I want to do it from a local installation of a wallet software, which I'll be doing here, is because that way I'm not sending my private key anywhere online. I'm actually just loading it into a local file, which is on my computer. So you're going to have to go through these awareness prompts. Here we go. Yep. It's a lot of prompts. Okay, and here we are. So as you can see, we're just actually running a file from my computer right now. And what we want to do is we're interested in this part right here, because this tab, which is really cool, will actually just let us interact with contracts. There are a few things that are needed, and you'll notice this is also true when we start interacting with our contracts from a front end using Web3.js, then we always need to know the ABI, the JSON interface. We're also going to need the contract address. And of course, the other thing that we need to do, because we launched all of this on the Rinkeby test network, we're also going to need to set our wallet provider here, which we've loaded from a local file on our computer. We also need to set that to Rinkeby. So we can choose Rinkeby from Infura. Of course, this is going to recharge the file. So now we have a fresh connection to the Ethereum network as provided by my Ether wallet, which we are loading locally on our computer. First thing we need is our contract address. So if we go here to where our deployed contracts are and click this, that should copy the value to the clipboard. Here. The next thing we need to do from Remix is get the ABI. So actually we're going to have to go back to the compile tab for this. Click the ABI. Value was copied to the clipboard. We can go ahead, paste that in this field. As you can see, Remix does give us a nicely formatted version, although the tab width is pretty huge in my Ether wallet here. Obviously, this is for selecting an existing contract. I was confused by that for a moment, but obviously we're just going to provide our own ABI interface here and our contract address. And hit access. It's actually loaded the contract now, but we need to choose what we want to execute on this contract. You can see that it did load the functions for us, and we should be able to start bidding. But in order to bid, what we need to do is paste the private key here that we took from MetaMask. And boom, we have write access. So now can go ahead and try to send a bid. Okay, we shall wait for it to confirm. Oh, looks like it has gone through, which means we should be able to see it here now. There it is. So it does look like a bid has gone through, which means we should be able to come back here into Remix. Look at our contract. Of course, once again, the beneficiary is ourselves. The highest bid is this value. Of course, this is the Ether value which I sent, which you'll remember is 0.11 ETH was sent. Now this value is in Wei. The format for converting a bid in Wei back to Ether would be to divide the Wei by this amount, folks. That is quadrillion. If we take the Wei amount and we divide it here by a quadrillion, you see that that is the actual amount of the bid. And of course, the highest bidder, awkwardly enough, happens to be the beneficiary. Of course, this is not a great real-world example. But of course, this is the kind of thing that you're going to be doing when you're developing your own smart contracts. When you need to test them, you will need to do things like set yourself as the sender and receiver.